Hello everyone, welcome to our talk on how Intuit streamlined schema evaluation in a federated graph. I am Ramapalaniappan, a principal engineer at Intuit's API management platform.
Hi, I'm Nitya Hariharan. I'm a senior software engineer at Intuit's API platform team.
In today's talk, we'll be covering what GraphQL shared types are, challenges encountered while evolving them across huge number of subgraphs, and how we solved it. At Intuit, we have lots of subgraph teams, and these teams share their GraphQL types. When I say shared GraphQL types, it means that they have the same type that would be defined by multiple subgraphs using the @shared federation directive. So what happens is when you are making any changes to these shared types, most often that requires coordination with other subgraphs. A lot of engineering time is wasted in this coordination. On an average, to get a change in the shared type, it would take around like 4 to 6 weeks. That was our previous state. So we just wanted to cover like how we approached this problem and the potential ways that you could solve it as well. So we'll explain what shared types are, challenges that we faced, and all of those in a role play. Basically, I'll play the role of a subgraph developer, and Nitya will play the role of an API steward. Like at Intuit, an API steward is an expert in API, and specifically in this case, GraphQL. And API stewards help mentor the developers who are authoring the API schema to do it the right way, the defined standard way. For the rest of the session, as a subgraph developer, I'll try to solve a requirement or implement a requirement. Whenever I hit a wall, I'll get help from Nitya, the API steward, and Nitya will help me understand the problem a little better and a way to solve it. So the first part is why shared types. So let's say I'm a developer in a payment subgraph team. I have a requirement to implement a feature to accept payment. Okay. So when you hear this for the first time, the normal one is you would think about payment gateway or something like that. So as a talk is related to shared types in GraphQL, and this is a GraphQL conference, we'll restrict all our requirements towards the GraphQL schema definition for this specific requirement and the subsequent ones in the talk as well. So for this requirement to accept payment, what I had to do is I have to define a type called money. So the money would have two fields, amount and currency code. Those are common stuff. But what should the GraphQL type for these fields be? For the amount, will the built-in GraphQL type called float, will it be good enough? Will it have enough precision? Or should I set it as a string and then convert it to a number or a whatever decimal format in my code? Should I do that? And what should the currency code be? Is there any standards out there? Should I follow or should I use my own stuff? I don't know all of these things. Let me ask Nitya how to define this money type.
So this is a pretty common use case, and that's why type money is available as a shared type. So this type adheres to ISO 4217 currency code standards and appropriate decimal precision for the amount field. Please note that it has been marked with shareable directive, which means that it can be resolved by multiple subgraphs without conflicts. This obviously requires that the type definition should be exactly identical across all the subgraphs using it. So this obviously ensures consistency and makes it easier to integrate shared types within a supergraph. Now, our API platform team provides some utilities specifically designed for importing and integrating shared types. The first step is to include the common types library as a dependency in your subgraph project. Now, this includes the money type, which is defined in the common types schema. The second step is to integrate the build plugin that we have implemented. This plugin generates a unified schema file which merges the common shared types with your subgraph schema. Now, this uniform schema file can be used in key processes like linting, publishing to supergraph, and more. As a result, money type is now available for you to reference in your subgraph schema. Let me reiterate some of the benefits that shared types has to offer. It ensures consistency. All teams use the same money format. It improves speed and developer velocity. In your case, you didn't have to reinvent the wheel. You didn't have to research about the various standards for currency code or the amount field. How do you define them? It's already done for you. It provides reliability. These are proven types with proper validation. And it also helps with federation, with seamless schema integration. Now, the common types library and the build plugin that I talked about, these have been included in our service template so that all new GraphQL services are will automatically import the shared types.
Thanks, Nitya. So now with the shared types, I don't need to redo something, and I'm pretty sure that I would follow all the standards that are set out at Intuit. So the next challenge is how do we evolve shared types? So now I have a new requirement to display the currency symbol. It's easy, isn't it? I just add a currency symbol field in the money type and let it be a string. So I hope it is simpler, but I get a composition error when I try to do a composition check. Let me ask Nitya how to fix this.
As I already mentioned, money is a shared type in the supergraph. All the subgraphs that are using it should have the same definition. Now, when you add a new field to the shared type, this change becomes backward incompatible, and that is why you're encountering this schema composition error. Now, for shared types evolution in a federated graph, it is recommended to introduce a new field to a shared type with a directive called inaccessible. This directive will make sure that the new field is not visible to the client, but allows your subgraph team to publish your schema to the supergraph. So your team is completely unblocked at that point. Now, only when the directive inaccessible is removed, the client can see the new field. And for this to happen, all the subgraphs that use the money type should include the new field. So our platform team has streamlined this shared type evolution process. Subgraphs teams are generally restricted from using the inaccessible directive, as it can unintentionally break client functionality. Our platform team has a test subgraph used in the shared type evolution process. Now, phase one is for you as a subgraph team to submit information about the new field and the type that you're adding it to. We will trigger a pipeline with the input that your subgraph team has provided. And then we will create an automated change request to add the new field with the inaccessible directive to the test subgraph. The third step is that after approval, this change request will be auto-routed for approvals. After approval, the new field with the inaccessible directive is deployed to the test subgraph. So at this point, your subgraph team is completely unblocked. And you can try to publish your schema with the new field to the supergraph. You will not encounter any schema composition error because this new field has been rendered inaccessible by the test subgraph. Now let's go to phase two. As I spoke about, for the new field to become accessible, the dependent teams has to upgrade their shared type to include the new field. So this is a phase two where we will identify dependent subgraph teams and send them auto notifications so that they can upgrade their common types version to include the new field. Let's see those steps. So first is auto-identify the dependent subgraphs using the shared type, in this case, money. Next step is to actually send them notifications along with the version of the shared types that contains the new field, so they can upgrade it. And the next step is that the subgraph updates the common type version. The good thing about this is that each subgraph can upgrade their common types version independently. They can add business logic for this new type. They can include test coverage, but they do it independently. Now, after phase 2, the only thing that remains is that we still have to activate the field for the client consumption. So at this point, the new field is ready to be activated. Let's look at phase 3. Once subgraphs are updated, then the new field will be activated. So what do we do there? Like, how do we automatically do that? We know that one step is to remove the inaccessible from the test subgraph so that the new field is visible to the client. But first, what we do is we confirm that all the subgraphs using the shared types have upgraded their common types library to include the version that contains the new field. So we automatically make a readiness check. The next step is to create an automated change request and remove the inaccessible directive from the new field in the test subgraph. So now the field is available for client consumption. So this is how our platform team has streamlined the shared type evolution process in a federated graph.
So after phase 1, as a subgraph owner who wants this new field, I am unblocked and I could publish the schema with the new field and start testing it independently without waiting for the other subgraph teams. And I don't need to actually coordinate with all those subgraph teams to address it. There is already an automation that takes care of it. But I still have to wait for all the subgraphs who are using this money type to upgrade to it for me to remove the inaccessible so that the clients can get the new feature. Is that right?
That is right.
Okay, thank you. So the next is how to evolve a shared enum. So let's go to the next requirement. So now I have a requirement to support cryptocurrency, specifically say Bitcoin. So this seems straightforward, isn't it? I just get the code for Bitcoin and add it to the currency code. That's as simple as that. When I searched the internet, Bitcoin seems to have a currency code called BTC. So all I do is add BTC, and looks like currency code is defined as a shared enum for us. So I'll just add the BTC as a new enum value to the currency code. But this also fails with a composition error. So what do I do? So should I go through the whole process of this at inaccessible in there? Let me ask Nitya on how to fix this.
So this currency code enum, it is used as both input and output type in the subgraphs that are using this shared enum. So the definition must be the same across all the subgraphs to ensure consistency. Because of this, adding new values to the enum like you did, you added BTC, it becomes a backward incompatible change. So the reason is that it can break existing clients who aren't expecting those values. So this is why you encounter the schema composition error. So I think one way to address the issue is that you already know we can introduce a field using the inaccessible directive. But in this case, in the case of an enum, which is shared, there is a more effective solution. Cryptocurrencies like Bitcoin, they're not part of the ISO 4217 standard for currency codes. Now, you know that Bitcoin is commonly referred to as BTC. As you said, you had searched and you found that. But ISO 4217 may decide to define it as XBT if it were to be added in the future. Now, over time, you may also want to add more cryptocurrencies to this list with customized currency codes. Now, it makes the enum values more dynamic rather than fixed. Now, in this case, a better approach would be to define the currency code as a scalar. Now, you can see this is how you define a currency code as a scalar in the GraphQL schema. Notice that there are no specific currency values in the schema. So the scalar definition becomes exactly identical across all the subgraphs. So evolution of the scalar is, can be done independently by each subgraph, and there's no coordination required. Each subgraph can handle any currency value without breaking federation. This is how we define the custom scalar for currency code in common types library. You can see that the currency codes are defined as a Java enum. And you can also see that new values of cryptocurrencies like BTC and ETH is added to it. And given below is the coercion logic for the scalar, which also has to be defined in the library. Now, this would allow to handle coercion and validation logic directly within the common types library. It makes it simpler and more consistent for individual subgraph teams to use. Now, say another subgraph wants to add a new cryptocurrency value to this list of currencies. So all they have to do is create a pull request and to the common types library. Once it is released, they can independently use the upgraded version. This will not impact the subgraphs using the older version of the scalar. So this is how custom scalar decouples in-graph coercion logic from schema change process.
Okay. Thanks, Nitya. So how do I decide what shared type should be a GraphQL enum versus a custom scalar?
Yes, it's possible to decide when you're designing for it. It actually depends on the values of the enum. Say you want to define a GraphQL shared type which has multiple values. Now, the one thing that you need to think about is whether the values will change over time. If not, it is good to define it as a GraphQL enum. Some of examples that I can give are, things, days of the week, like Monday, Tuesday, which you don't anticipate for it to change over time. Months of the year, January, February, etc. So those are some of the values that you don't anticipate that it will change, and it's good to define them as a GraphQL enum. Now, if you anticipate that the values can change over time, then it is good to define the shared type as a custom scalar, like we just discussed. Some examples are currency code, like we discussed, country codes, language codes that you anticipate will get added in future or removed.
So this is specific for the shared type specifically?
That's right.
Okay.
Only like for shared types, you decide based on the values.
Okay. The next is how to prune schema of unused types. Let's see, are there any other strategies to manage evolution at scale, especially for the GraphQL shared types, Nitya?
Yeah, there are. So we learned this the hard way. So our tooling would publish all the shared types from every subgraph, even if they only used a few of them. You know that this creates massive coordination overhead. Imagine like talking or having to coordinate with 50 plus teams every time someone wanted to add a field to a shared type like money. So to reduce this coordination burden, our platform team built schema pruning feature in our build plugin. Remember I had mentioned about this build plugin. Adding this would help integrate shared types into the subgraph. Once newer version of this plugin is available, or it's imported, every subgraph only publishes the shared types it actually uses. This dramatically reduced coordination burden and made evolution much more manageable. We've also updated this newer version of the plugin in our service template so that every new GraphQL service created will have schema pruning in place.
Like, how do you identify that this, the type is being used or not used?
What do you think?
So is it?
We parse the schema and we see whether it is being referenced
Okay.
or not.
Okay, so reference through the queries or the mutations,
Yes.
and if you don't have any reference at all, but you
Yes.
still have those, so you
Yes.
just that.
So we
means it's not
start with the
referenceable.
root type
Okay.
and we
Okay.
dig in deep and then see which types are being referenced and which are not, analyze them, prune those
Okay.
unused types, and then voila, you get the ones which are actually referenced to, actually merge with your subgraph schema and publish it. Oh, let's look at your subgraph. We'll see the difference when you consolidated the schema with the shared types without schema pruning. Look at the subgraph. It has like about 74 types, like almost 54 common types, which are unreferenced, but they have been included in your consolidated schema. Now, these will be published, unnecessarily creating coordination burden when you have to evolve these shared types. After schema pruning, you can see that our schema pruning feature has intelligently pruned 74 types. So your schema is much more concise, and this reduces the coordination overhead.
Okay, thank you. So the results of these three activities that we did on schema, evolving shared type schemas are here. Next slide, please. So the first thing that we did was inaccessible automation. So that eased the coordination burden and enabled faster delivery. So the custom scalars allowed subgraph teams to evolve the enumerated type without coordination. Schema pruning removed a lot of subgraphs from the coordination scope. But it's not removing the coordinate. It's still, if you are using a shared type and it is referenced, you still have to go through this at inaccessible automation. But those that are not using it, they are not part of this coordination scope. So that also helps in getting delivered things faster. So that's, next slide, please. So with these three things, like at inaccessible automation, custom scalar, and the schema pruning, so we are able to go from like 4 to 6 weeks of evolving a shared type to 2 to 3 days. So the reason for 2 to 3 days is we still have some subgraphs. We have to coordinate with them. And the 2 to 3 days is not all the way to production, at least in a pre-prod environment, you could still have those teams upgraded and so that you could test out the whole supergraph as well. So that's the thing here. So the key takeaways for us. So use shared types in a federated GraphQL schema. This will help represent the same concept using a consistent type across all subgraphs within your supergraph. And shared type avoids work duplication. So use it there. But most changes to the shared types require coordination between subgraphs. So think about ways in which you could eliminate the coordination completely, like as we did with the custom scalar. Like we changed the GraphQL enums that are shared types to a custom scalar. So that is complete elimination. If you cannot completely avoid it, try to reduce the coordination scope with, say, schema pruning kinds. There could be changes that cannot be avoided and would require coordination between subgraphs. In those cases, ease the coordination burden by having an automation like we did with the at inaccessible automation. So the final thing is, as humans, we tend to categorize and classify things. This is how we understand the world around it. There's nothing wrong in it. But we cannot make up our mind most often. Okay? So some examples. Pluto was a planet once. Now it is not. Okay? Tomato is a fruit scientifically. Legally in the US, it is a vegetable. Okay? So we keep on changing whatever we classify or categorize it. We cannot make up our mind, and that is normal. So whatever GraphQL types, whether shared or not, whatever you're defining, it's bound to change. Okay? Don't think it is set in stone, it is bound to change. So especially if it is a shared GraphQL type, and if you're going to change it, it has associated cost with it. So make sure you use this GraphQL shared type sparingly and only when required. When it is required, it helps have a consistent interface, but if it is going to change a lot, don't try to add it as a shared type in the first place itself. Wait for it, let it evolve. Once it is a little bit more stable, then add it to the shared type. So that's it from us, and we are open to any questions.
How long does it take to get the rest of the teams to? No, I'm okay. How long does it take to get the rest of the teams to actually adopt that?
The question is like, once you add the inaccessible, how long does it take for other subgraph teams to update to the newer field or newer common types? So that depends on the kind of addition that you're going to do. So there are cases where the new field or a new type or value that you're adding, it might be totally irrelevant to that team. Okay, they don't need to implement that new feature at all. So in those cases, it's just a simple change of version for the common types, and those kind of stuff, it is easier for the teams to do it, and they do it faster. But if there is, like in this case example, a currency code that we added, like a Bitcoin or something like that, and everyone has to support it, that has its own thing. It's not just the schema that we are talking about. It is an implementation that has to go with it. So in those cases, it's going to take time. So it's not, as I said, it's an average time. A lot of things, people don't really care about it. So the way they handle it is, if you get this additional enum, so they will say, okay, I don't care, I don't know how to do it, so I'm just going to throw an error out. So if that kind of stuff, it's easier to get the change done faster. But if the change requires an implementation and the implementation might be different or difficult for them, it would take longer time for them. So wait for the mic so that others could hear your question.
Coming over.
Sorry.
Hello. Quick question. How do you handle a situation where a type or a field might be referenced in the schema, but it's actually not being used?
We are not handling that right now.
Okay.
As long as, because we don't know whether, if there is a reference, we are not scanning the code there. All we are trying to do is just scanning the schema. So if it is referenced, we assume it is used.
Because it could happen, right? Like someone wrote a query and at some point it's being used, but then it got cleaned up, and then the subgraph developer
you could
forgot
still get it from,
Yeah.
say, if you look at the Apollo Insights or other parts, like you can get to know which fields are being used. So if you think, if a field is not being used at all by no one, then you could potentially deprecate it, but you could use the different mechanisms to do it. But right now, we are not doing it that way.
And also, if you use the newer plugin version that we have implemented, that actually prunes the.
No, his point is there is a reference already, but it is not
the
actually
ones which are
used.
already there can't be done, but the newer ones, obviously, that's the idea of schema pruning.
Okay, thank you.
Is there one team that owns all of the shared types, or how are you doing like the ownership detection of, hey, I'm changing the money type that's owned by the money team, I need to send it to their Slack channel or something? How are you handling that?
Yeah, so our platform team owns a library called Intuit common types. So we anticipate that this will be used across Intuit. If it's specific to a business unit, usually they are the one who own it, and we kind of recommend ways to work around this problem, and they own the thing and implement the solution that we recommend.
So basically, the thing is, like, we have multiple levels of the shared types there. One across the company, others could be shared types within the business unit. So they could share within their business unit, but at the end of the day, from a GraphQL point of view, it's a shared type. Irrespective of what hierarchy you are having, you are going to face the same set of issues if you're going to evolve it. So we work with other business units who manage the shared types as well, so with them. So that's how we help them.
Yeah, so I had a question regarding the pruning in particular. Are we talking about tree shaking, or are you talking about just going through and just wholesale removing the item? So from a subgraph, if I'm not using the type, yeah, okay.
So basically, when we say schema pruning, we are not removing it from the subgraph implementation. We are just removing it from the schema that is published to the supergraph. So like in your case, if you're using Apollo Studio, like when you're publishing it through Rover, at that point in time, the schema that is published, that has only things that are referenced. All unreferenced are removed there. But the actual code still has it. So we are not removed because we don't own the code. Like we own the publishing part of it. We could take it, and that's a safer thing for us to do. We are not touching the actual code at all. There's one at the back. Oh, sorry. Go ahead.
Hello?
No work.
Done? Okay, great. You just answered one of my questions, actually. It was about where in the exact process does the pruning happen. It's at the publish step, which is part of your CI/CD process, I guess.
Yes.
The other question was, when the teams that are using these shared types with the common library, they want to run the merge tool, right, to bring the types into their schema. When exactly do they do that? I mean, is that a manual step, or how does that work?
So
Yeah, you mean the consolidated schema? How do you create it?
Yeah, I mean, you're going to need that because you're going to have to write your resolvers if you do need to implement.
Right.
Yeah. So basically, what we do is like we have this. We use Maven and Gradle across our stuff. We have a build plugin in there. So what it does is it runs as part of the building your application, the subgraph application. It has this. It goes and checks all the GraphQL schemas that are available in that particular binary, or in this case, a WAR file or a jar file, whatever it is. It goes, scans all of them, and concatenates and creates a unified schema file first. Then it goes through, it does another iteration and figures out what are all the types that are referenced and not referenced. But all those not referenced ones will be removed, and only a new file would be written with only the referenced pruned schema. So that's the schema that will be used for any sort of linting as well as schema publishing, or anything that we expect out of the subgraph as a GraphQL schema that is published outside of that team. That's the thing that is being used, and that's done as part of your build process itself. Yeah.
Hi. I have a two-part question. First, with the enums that you put as scalars, how do you manage the data contract between like the client to know what data is going to come in that scalar? Do you handle that somehow, or they just get it? And have you thought about moving all common types to scalars?
GraphQL enum actually helps in doing those parts better. But the problem with that is, like, especially if you're having an output type, so then the clients would expect it to have only a finite set of values for that particular enum. And the moment you add a new one, they would bomb. Basically, it's a new value that they don't understand it. So they may not have a coercion logic at all. But if you don't have enum at all in the first place, if you're just doing a custom scalar there, from a client point of view, everything is an unknown. So it has to figure out like what it has to do. So right now, the only way that we are looking at is documentation. So in the documentation for the custom scalar, it would say that, okay, this supports, say, the currency code. This supports ISO 4217 plus these other Bitcoin currencies. And we would also have a list of all the values that are there. So that's the documentation is the only way to do it. So when a client is being created, so they should look up for these, and they know what all things that they can expect. So it is a little bit harder. It's not, if it is a GraphQL enum, it is easier for them. It's all taken care for you. But the evolution is harder. So that's a trade-off that we had to do that.
And also when the client calls, like he's going to provide a currency code, the server-side validation happens in the common types library. I think I showed you the coercion logic. That is where the validation happens. Whether it's a valid client is, yeah. There's no client side.
So basically, the intention there is like, if you, with those documentation, the client can think that the server is going to give these values there. If you get anything outside of that, you could have a graceful way of coming out of those and give an error for the client. So that is a possibility. And say in the case you add a new value in there and the client is not updated and it still expects older values, it will fail. So when you have a failure, it is easier to do it. Like otherwise, if you just change it, so you may not even handle it gracefully. It could break it in an odd or a bad way.
And I think he had a second question.
Yeah.
So yeah, to answer your second question, we have converted all the GraphQL enums which we think that, whose values we expect to change over time into custom scalars, not the ones that we don't anticipate.
So if you're starting fresh, think it this way, because we had to add a deprecated we'll have two different shared types, and GraphQL doesn't have a namespace. So if you have a currency code as an enum, then you cannot have another currency code as a scalar. So you have to have something else as a currency code as a scalar. Then that name match will be a problem. So if at all you're adding, especially a shared type, if you're adding an enum, think a lot, because you may not get the same name back.
Hi, thanks for the session. I have a couple of questions. First is, for pruning, are you using LLMs for doing the pruning?
No, it's a normal, simple tree traversal there. You should be able to get that done.
And second is like when you said like you migrated from the enums to scalar, custom scalar, right? Are you guys using persisted queries or mutations, like all these operations, right? Like, so we have similar situations. So we are actually working with inaccessible. We have like 70 plus subgraphs, right, who are having as an input and output both ID type enum same actually. So like how you guys have done actually like moving from enums to scalar. So did you had any impact with your consumers, like all your experience?
So as I said, like you cannot, with any GraphQL change, we cannot just like that remove enums out there. We just marked it deprecated. We just have to monitor who's using, which client is using, and have to have a reach out to them to go migrate there. From a persisted query point of view, it's not exactly the same. Like persisted queries, you could consider for this use case, the query and those things are vetted and validated. So you could go check whether those persisted queries use these enums, can it be changed to custom scalar? But it's not only that. Even if you accept things outside of persisted queries, you have to look for all the queries and figure out if people are still using that deprecated enum. You need to reach out to them and have a migration or a plan to move it out to the custom scalar. So it's any other normal GraphQL type evaluation. So there's nothing different there. Yeah.
Hi, thank you for your presentation. I have a question. Can you talk about your schema governance process? So how did you come to decide what types would be shared in your library? And also, like, did you look through all your schemas across your subgraphs and say, I will take ownership over this shared type because I'm seeing there is this reoccurrence across our subgraphs? What was like the process of telling all the subgraph teams, like, we're gonna distribute this library, you no longer have to provide this?
So as I said, like we have a set of APIs towards across the company, and we let those domain teams take the decision what is shared between their teams. If we all see, since we could also see the subgraph, so the supergraph as well coming in. So there was another session from Alex and Oleg's earlier. So we had something called as collision checker. So what happens is, assume if you are having something new, like in this case, say money as example. So you already had created money, and I didn't know that this money existed in the supergraph at all. And I also go create something money, and I see some problem. So what I do is I just say money amount or something else, and then publish it. So what this collision checker will do is, okay, there's already a type called money that's available in supergraph, and you are trying to create a new type called money amount with a similar kind of fields. Most likely it is a duplicate, is what that collision checker will identify. So, and as part of our governance process, we have an API. Though we do a lot of AI-related governance out there, we still have the final human has to finally approve it. So that person would also be presented with these collision checks and other parts. So that is one way for the API steward to say that, okay, this money is being used across multiple subgraph teams. This has a potential to be a shared type. Right now, they could potentially say it without going to the common types and other parts. They could just share the same type definition across these two subgraphs and push it out, and eventually move that shared type to a particular common type, either at the business unit level or at the company-wide level. So that is a thing that would happen later. But you would have certain checks that would happen beforehand, so that way, that's how the teams are getting. We are not actually having a brainstorming session, what all things should be. This one, like, we check as we go. Thank you.